Okay, welcome back. Today we are going to look at a priority encoder. This is listing 3.1 in your text. So let's bring up some notes here on a priority encoder. And let's see, the idea here on a priority encoder is that you've got four inputs. Okay, so here's my input R. And they can all be 0, or they can all be 1, or you could have 16 possible combinations. And you can think of these inputs as requesters, and each one has a different priority. 000 would be no one's requesting. 0001 would be the least R0 is requesting. And then down here you've got all four of them requesting. So think of these as like people or interrupts on a computer requesting attention. And the lowest priority would be the least significant bit, and the highest priority would be the most significant bit. So down here, notice that the most significant bit is being asserted, but so are some of the lower bits. Well, when the most significant bit is being asserted, it has the highest priority, and we output a 4, indicating that R4 is being asserted. And then on these four right here, we'll notice this bit is being asserted, R3, so we always give it to 3 regardless of what 1 and 2 are doing. And then here, 4 and 3 are not asserting, but R2 is asserting, and so is R1. Well, we always give it to R2. And then if only R1's asserting, we give it to him, 1. And then if nobody's asserting, we output 0. So this is kind of like an interrupt requester. We basically output a P code telling us which one of these guys is requesting and which one has the highest priority. Now, you don't really need this entire truth table. What you could do is express it over here. If R4 is asserting, then that means ignore everybody else, because this is the highest priority interrupt, and then output a code that says 4. Now, if R4 is not asserting and R3 is asserting, ignore R2 and R1, because you're going to give it to R3. And now if R4 and R3 are not asserting and R2 is asserting, then give it to R2. Doesn't matter what's happening on R1. Then R1's the low priority, right? And then if R4, R3, R2 are not asserting, and then R1 asserts, give it to R1, and then if nobody's asserting. So the bottom line is we look for the highest priority line, and that's kind of a way you can kind of prioritize interrupts in a processor. So this is the truth table we want to implement with VHDL. All right, so let's go ahead and do that. Let's bring up ISE Project Navigator. Let's do a new project. And let's see, what do we want to call this? We will call this, actually I don't want to go there. I want to go... Let's come down to here and go to 360 and probably somewhere in here. And let's see, this is still, okay, chapter 3. We'll put it in chapter 3 and we will call it listing 3_1. Yeah, listing 3_1. HDL, next. Let's see, we are using a Spartan 3E in lab. The chip is in the Spartan 3 family is the CS3 or C3S500E, flat grid 320, speed -4, synthesis tool. That's fine. That's fine. We are using VHDL as opposed to Verilog, and then we'll use the 93 standard, which is fine. Next, and there's some information and finish. All right, so at this point right here, I can come along and I can say new source, and it is a VHDL module, and let's just call it, what file should I call it? How about listing, actually, what do I call the first file? Yeah, how about this? Well, let's just call it the same one as the project, I guess. Yeah, listing 3.1. Okay, it's a VHDL module, and here I can specify my inputs and outputs. Well, let's go back and look at what this had. Well, we had 4-bit input coming in on R, and then we had a 3-bit output called P code. All right, well, let's go ahead and do that. Let's come in here and call this guy R. We'll call this one P code, priority code, and then R is an input, P code is an output. Now these guys are more than 1 bits. R is a bus, so let's call it 4 down to 1. And then P code is an output. What I'll do is I'll call it 2 down to 0. So notice I'm calling R going from 4 to 1 as opposed to 3 to 0, because when R4 asserts, I want to output the binary value of 4 here, but P code is going from 2 to 0. All right, I think that's all I need there on my entity. And I'll finish that guy, and my entity should pop up here. All right. And let's get rid of all the comments here. I don't think we're going to need those. Just kind of clutters things up. I have limited real estate. Well, there is my entity right now. And I called this guy listing 3.1. I probably should have given it a better name. I probably should have called it priority encoder. Okay. Well, here's your entity block, and there's your port. There's R. R is an input. It's of type standard logic vector, and it's 4 bits, 4 down to 1. P code is an output, standard logic vector, 2 down to 0, 3-bit output. There's my entity. Right, you got your entity. Now here's your libraries. We're not doing any arithmetic or anything, but we do need the standard logic 1164 to use the standard logic vector data type. So at this point, what we can do is I don't think we need any variables here. We can actually just write this guy straight away. What's P code equal to? Well, P code is going to equal to 4 when what? Well, when the most significant bit of R is asserted, right? There you go. Yeah, so if R4 asserts, we don't care what's going on in R3, R2, R1, and R0 or R1. Yeah, we just basically output a 4 because R4 has the highest priority. And then what you can do down here is say, well, let's see. Assume R4 is not asserting, and let's say, well, is R3 asserting? Right. There you go. So now if R4 is not asserting, then we're going to get down to this line, and we check to see if R3 is asserting. Then we're going to output a 3. And then we can pretty much just copy this line, Control C. And let's see, and I think I can do that. Yeah, so I am going to output a 2 when R2 is asserting, and I am going to output a 1 when R1 is asserting. And if nobody is asserting, then I am just going to output 0, 0, 0, and I will end that with a semicolon, and that should pretty much be it. We've just implemented a priority encoder. Okay, and at this point, let's see. We're not going to implement it. We're going to simulate it. So we've simulated it. There's my project. There's my file. I wonder if I could rename that guy. Nah, I won't go there. And then we select it. Come down to the processes window, and we check the syntax. Get some stuff spewing out down here. Okay, so it compiled successfully. So I'm done. Yeah, I have successfully implemented a 4-bit priority encoder. All right. So the next step is to simulate this guy. We'll do that in the next video. All right. See you later.